Hello and welcome to this video on molar conversions, which is this unit's most time-consuming thing. Every unit has to have those problems that take you forever with all the little numbers to write. But anyway, so I think moles is the main part of this unit, and moles are pretty simple once you start to understand them and, have some practice with, which we've had lots of practice with the owls, but nonetheless, I'm going to go over it again. So, to start, as you probably talked about in class, there was an Italian scientist named Avogadro, and so the periodic table, all the masses on there are in atomic mass units. And he's like, well, humans don't think in atomic mass units, we think in grams, because atomic mass units are incredibly small. And so he decided to redo all the masses on the periodic table so that they were in grams. And because of this, he got a number named after him, which is called Avogadro's constant. And what Avogadro's constant is, it is the number of carbon atoms in 12 grams of carbon-12. And it's basically a conversion factor. And this number is huge, but we simplify it down to 6.02 times 10 to the 23rd. That is a very important number of this unit and probably for the rest of chemistry. So that is Avogadro's constant. And so what you can do with Avogadro's constant is it allows you to convert to and from moles. And so what a mole is, it is the quantity of items equal to Avogadro's constant. I'm just going to leave it like that. So a mole is basically like, another, like a dozen, or, numbers a pair. It's just another, it's a number. You have moles of something, and you don't just, it's not a unit. You have moles of carbon. You have moles of hydrosulfuric acid, and so 1 mole is equal to Avogadro's number, as I said, which is going to come very handy. So it would be like 1 mole is equal to this things. Or you would say I have 1 mole, and that's the abbreviation of things. So 1 mole of any substance has a mass in grams equal to the formula. So 1 mole equals the formula mass of anything. So you get the formula mass, you can convert it to moles. So say there's also a thing called molar mass, and molar mass is again found like formula mass, and it's just 1 mole of a substance that has a mass in grams. In grams equal to the formula mass. So if you had a problem that asked you to find the molar mass, it's basically asking you to find the formula mass, except instead of putting U's or AMU's on the end, you put G for grams. So say we want to find the molar mass of calcium chloride, CaCl2, and then we just do the thing, but now we're in grams. So 40.08 grams plus 2 times 35.45 grams and we would get 198 grams of calcium chloride, which would also be, so that's the molar mass, but that would also mean 1 mole calcium chloride would be 198 grams of calcium chloride. So that's kind of how those conversions work. So there are 4 kind of possible conversions you could have with moles. And these are important to know. You've probably been using them already. There you can have one mole of a molecule equals Avogadro's number molecules. 1 mole of formula units equals Avogadro's number of just formula units. Form units. 1 mole of an atom equals Avogadro's number atoms. And then 1 mole of a substance equals molar mass. Molar mass in grams of that substance. I don't think I need to write that again. So those are your 4 possible conversion units. So if you're converting, you see molecule, formula units, atoms, you're going to use Avogadro's number in there somewhere. If you don't see any of those 3 words, then you don't need it, and you're just going to convert. It's basically a dimensional analysis, which we learned earlier in the year, and that's kind of it. So I'll do, I think, 1 example, 2 examples, and then if y'all are still confused and you want more examples, I can make another video of just doing examples from owls or notes and stuff of how to do these conversions. So here's an example. Say we want to get moles, or so how many moles in 10.5 grams of CH3CH2OH? So, first things first, you need to find the formula mass of this. I'm not going to write it all out, but I have written down that this is the formula mass of that substance. So, the way you do this is you start with your given, which is 10.5 grams of all that. You put it over 1, just like dimensional analysis. And then we want to get to moles. So remember, for dimensional analysis, you put, you need to cancel your units out. We have grams of this substance on the top, so we want it on the bottom. So we put that formula mass on that bottom. And then we just put 1 mole on top, because 1 mole is equal to the formula mass. And then you just plug this in your calculator. So you just 10.5 divided by 46.08, and you get 0.228 moles of this substance. And just remember sig figs when you're doing these. Yeah, so I think we kind of get that. Let's do one with where you need Avogadro's number Say how many ammonia molecules are in, I think this is 10 million grams of ammonia, which is NH3. So again, start with your given, which is this very long number. I've not choose a good sample. Start with that. So if you're given grams, or you're given grams and you need to get to molecules, atoms, formula units, you need to first go through moles, because that's the only way. Moles is kind of like that bridge between the two. You have to go through moles to get to the other stuff. So you take that and you convert to moles. So you get ammonia's formula mass, which is 17.04 grams of ammonia, and you put that over 1 mole of ammonia. So now these cancel out, and then now you're going to get it into molecules, because you can go straight from moles to molecules. We know we want the moles to cancel out because we want to be left with molecules, and then just put Avogadro's number on the top there, and then molecules. Probably don't need that of. Oops, I've been writing this in the wrong order. That's great. Okay. And then, so now the moles are all gone, so now we are left with molecules. Put this in the calculator. Now remember, when you're doing 10 to the blank, you just hit that E. So when you type this in the calculator, you'll type 6.02. That EE button, that's what it is on the graphing calculator. I'm not sure, that's what I've been using. But it'll show up as E and then 23. No multiplication sign, no nothing, just that. And then, you'll put the rest of this in, and that will give you 3.53, because you have 3 6-figs here, times 10 to the 29th, ammonia molecules. That is a lot of molecules, but that is it. So that's kind of the basis. Just remember, if you have a diatomic, remember if it wants like atoms of that molecule, remember those. I guess another one is, say it wanted hydrogen atoms, and how many hydrogen atoms are in 10.25 grams of ammonia. So we start with our given. And then multiply by the formula mass, which we just got, over 1 mole. So that's the conversion rate. So these cancel out. So now we need to get it in. We want hydrogen atoms, but we can't go straight to atoms because we're not just dealing with hydrogen by itself. It's in a compound. It's a molecule. So we're going to convert these moles we now have into molecules. So Avogadro's number up top. Over our 1 mole. So now these are gone. Now we're in molecules, but we still need to get hydrogen atoms. So for every 1 molecule, because we know ammonia molecules have to go on the bottom, so we can be left with our atoms. For every 1, we see there are 3 hydrogens. So then we're just going to put 3 hydrogen atoms up top. And that's how you get those if it just wants it by itself, because these now cancel out. And then you're going to take this whole long equation, plug all of this into the calculator, and then you will get that there are 1.09 10 to the 24th hydrogen atoms and 10.25 grams of ammonia. So those are probably all the ones you're going to run into. Sometimes, this one it wanted moles, maybe it'll want grams, give you moles, but it's basically the same process. Just remember, you want to cancel out top and bottoms to be left with what you want. And yeah, that's the main thing you need to remember for these. Yeah, that's it. Just a reminder, I'll be having a review session for the midterm, December 12th at 2 p.m. If it will be on Zoom, just contact me in some way for the link, and I will record it if you can't make it. Please subscribe so I don't have to send out text messages about when these videos are up. Yeah, and that's about it. I hope this makes some sort of sense. I think it's pretty good once you understand. And if you think about it like dimensional analysis, I think, at least for me, that really helped me think about it and be less overwhelmed by it. That's all I have. Thank you so much.